Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous lecture we have discussed about the occurrence of group 16 elements, as well as we have also discussed about what are group 16 elements. So now in this topic we are going to talk about the trends in physical properties of group 16 elements. So what are those? Let me talk about that in this topic. So friends, in this topic I am going to cover a few points related to the trends in physical properties of group 16 elements. So starting with the first one, that is physical state. So if we talk about the group 16 elements, obviously it starts with oxygen and it ends with polonium. But it has been found that is the oxygen is the only element in the group 16 which is present in a gaseous phase, while the rest of the elements, that is from sulfur to polonium, they are present in a solid phase, or they are present in a solid state. So this is the difference between, that is, the oxygen and the rest of the elements of group 16. So this was related to the point physical state, and now let me talk about the next point. And the next point is atomic and ionic radii. So it is but obvious to understand that is, as we move from top to bottom along the group 16 elements, we'll get to know that is oxygen is the first element and polonium is the last element. As well as we also understand that is the atomic number, it rapidly increases. For example, if I talk about oxygen, the oxygen has an atomic number of 8. The atomic number of sulfur is found to be 16. So that's the reason that as the atomic number goes on increasing, obviously the outermost shell, or the number of shell, also increases, and because of which the atomic size, or we could say that is atomic radii, also increases. So that's the thing, that is ultimately we have got to know that is if we move down, that is from oxygen to polonium, the atomic size increases. And that was the point related to the atomic and ionic size. And now let us move on to the next point. The next point is about density. So what trend we can find in density for group 16 elements? This is what I'm going to talk about. So as we have discussed earlier also, that is as we move from top to bottom, that is from oxygen to polonium, obviously the atomic size increases. But this atomic size increases with the increase in the electron also. That's the reason the density of this electrons, or the density of these elements, also increases, because there is not a rapid increase in the size of the atoms when we are relating it with, that is from oxygen to polonium. So obviously there is no rapid increase in the size. In fact, the increase is very much little. That makes the electron to be more densely acquired on the nucleus of those elements, and that's the reason the density increases as you move from top to bottom, that is from oxygen to polonium. So that was a point related to the density. And now let me talk about the next point, and that is electronegativity. So it is the tendency to acquire the electron in a bonded molecule. So that's the reason that it has been found that is the fluorine, which is the most electronegative element in the whole periodic table, and the second element after fluorine which is more electronegative is basically oxygen. So in this case, basically that is from oxygen to polonium. If you talk about that is group 16 element, then oxygen is the only element which is very much electronegative compared to the rest of the element that are being present in group 16. So oxygen is more electronegative, and after that we could say that is sulfur is less electronegative, and therefore the electronegativity actually decreases down the group. So therefore this was the point related to the electronegativity. And now let me talk about the next point, and the next point is melting point and boiling point. So talking about the trends in the melting point and boiling point of group 16 elements, it has been found that is as we understand that is from oxygen to polonium, obviously the density increases, and because of the density increases, because there is also the other possibilities of van der Waals force, and because of which we can find that is the melting point or the boiling point, this will also increase. But there is a short difference, that is what I am going to talk about, that is the difference if we talk about the oxygen and sulfur, because oxygen is basically a gaseous molecule and sulfur is basically a solid material. So because of which the melting point or the boiling point difference, obviously it will be very much vast. But if you talk about the tellurium and polonium, in this case we'll get to know that is the polonium will have a lesser van der Waals force, and that's the reason that the melting point or the boiling point is comparatively less than the tellurium. So therefore this was a point where we have found a difference, where we have got to know that is the tellurium has more melting and boiling point, that is higher melting point and boiling point compared to that of that is polonium. So therefore this was the point related to the melting point and boiling point. And now let me talk about the next one. So talking about the next point, that is we have electron gain enthalpy. So we already know what is electron gain enthalpy. It is nothing but the energy released when 1 mole of an electron is accepted by an atom. So in this case also I'm going to talk about the trend of the electron gain enthalpy of group 16 element. So in this case we have got to know that is the oxygen, which is more electronegative element in the whole group 16. So in that case, basically we can find that is all the electron cloud that are around the smaller oxygen atom, because if we talk about the atomic size, oxygen is the more smaller atom in the whole group 16, or we could say that is it has a lesser atomic size, and because of which, since it is more electronegative also, the electron cloud will surround that nucleus, and that's the reason an electron whenever an electron is been accepted, it will try to repel it, and that's the reason the energy will not be released more as we have expected. So that's the reason that the sulfur will have more electron gain enthalpy, and that's the reason that if we move down, that is from sulfur to polonium, the electron gain enthalpy it decreases. And that's the reason I want to talk about here, that is if you talk about oxygen, so oxygen has basically lesser electron gain enthalpy compared to that of sulfur, and the rest of the thing it will move to, that is polonium. So this is what I want to talk about. And now let me discuss about the next point, and the next point is metallic character. So talking about the point metallic character, we have got to know that oxygen is basically in a gaseous form while sulfur is in a solid form. But this oxygen and this sulfur, they both are basically non-conductors. And talking about the next elements that are basically belonging to group 16, that is selenium and tellurium, so they are basically metalloids. And talking about the last one, that is polonium is distinctively metallic in nature. So therefore this were the metallic character, and this is what I want to discuss about. And now let me talk about the next one, and specifically about catenation. It has been found that is the oxygen atom, it has a lesser catenation compared to that of the sulfur. And if we move down, that is from sulfur to polonium, this property of catenation it actually decreases, and that's the reason sulfur is the only element in the whole group 16 which have a tendency to show catenation, and this tendency can reach up to S8 also. So that is this puckered structure of that is sulfur, that is S8, it consists of 8 sulfur, and this is what the catenation is. While if I talk about oxygen, so oxygen can form basically maximum to maximum, that is H2O2, and in this case the oxygen can be attached to other oxygen. And suppose if we talk about that is ozone also, that is O3. So if we compare ozone, which consists of 3 oxygen atoms, and if we compare that is sulfur, that is the puckered structure of sulfur, and that's the reason sulfur is the one which has a tendency to form catenation. So this was related to this point. And now let me talk about the allotropy. So talking about allotropy, and suppose if I'm talking about oxygen atom, so oxygen atom are basically have 2 allotropes, and those 2 allotropes are O2 and O3. O2, that is nothing but dioxide, and O3, that is nothing but we know it as ozone. And talking about the next one, suppose if I talk about sulfur, so sulfur have many allotropes, and those allotropes they are basically alpha, beta, gamma, homocyclic, plastic, sulfur, etc. So this was related to the sulfur. And suppose if I talk about the next one, suppose that is selenium. So in this case selenium has different allotropes, and talk about that is crystalline selenium. So crystalline selenium are of basically 2 types, and that are basically red selenium, or we could also call it as the other one as monoclinic gray selenium. And now let me talk about the next one, that is suppose if I talk about amorphous selenium. So in this case we'll get to know that is the amorphous selenium have basically allotropes, and those are basically brown selenium and red selenium. So this was related to the selenium, that is we have discussed about oxygen, we have discussed about sulfur, we have discussed about selenium. And now let me talk about the next one, that is tellurium. So talking about tellurium, so tellurium has 2 allotropes, that is non-metallic and metallic tellurium. And talking about polonium also has 2 allotropes, that is alpha and beta polonium. And in this case alpha polonium and beta polonium, the both are basically metallic in nature. So therefore these were all the points related to the trends in the physical properties of group 16 elements, and that's it. question. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe to Ekeeda channel. Thank you so much.